2 years ago, I found myself facing a wall. It all began with a NASA paper that said, "We still do not know the reason behind this phenomenon." I was shocked, so I tried to research it, but I couldn't. Because I needed a $5,000 power supply to test my model for the force generated in an asymmetrical capacitor. The problem is that this source costed $5,000. Since I couldn't buy it myself, I thought I could build one. It was based on the technology behind old TVs, which used a flyback transformer for generating images. I salvaged an old broken TV from a storage downtown, but this one was so old, it didn't have any data sheets on the internet, so I couldn't connect it. But transformer design theory is universal. So I measured their pair pin resistance, fed the transformer backwards using a DC supply and mapped their connections until I finally found its coil configuration of its polarity. And after all of this, I published my procedure online for DIY TV repairs, so everyone can see it. Now I had to figure out the fun part. How to drive this small transformer up to 80,000 volts. The flyback is not an ordinary transformer. Different rules apply to it. I designed a circuit that could drive a power MOSFET using a 555 integrated circuit, which would sort of work as a pulse width modulation system. And after all, I set it to work between 15 and 60 kilohertz. In theory, this should have worked, but in practice, not so much. Suddenly, the MOSFET began overheating and then it blew up. So I got a heatsink from a broken control board that I found. I decided to dissipate the heat using 1 ohm resistors and changed MOSFET models twice. After a lot of changes, it finally worked. However, the voltage produced still wasn't good enough. I wanted to be even more stable. So I modified the circuit again. I decided to connect 2 capacitors in parallel to the primary winding, which in theory would serve as a filter. I found these huge condensers from old machines and began combining them, trying and mixing. After everything, the output looked like this. It had a voltage so high, it breaks air insulation and it jumped cables. After all, I enclosed it in a nice wooden box, because safety first. And there's something even more interesting here. If you hear this, different voltages emit different sounds. And this one does not come from the transformer itself, but from the electric arc. Can you imagine using it as a music speaker? And perhaps a frequency variation system that could control the flyback's duty cycle could do the trick. Now this circuit is a first step. The oscilloscope shows very small variations, but it definitely needs refinement. Every once in a while, makers find a make or break moment. For me, it was to build a power supply based on industrial rubbish. It made me face my reality, build my own opportunities, and learn about things that I had never seen before. That is why I want to go to MIT. Because, as I've seen, I still have a lot to learn.